Namaskar. Today we will be learning about signaling relays. This presentation deals with the characteristics of different type of relays, especially the plug-in type of relays which are used in railway signaling system. Basically, these are plug-in type relays which are generally used in railway signaling system. Apart from that, there are other relays also like polarized relays and K50 type relays, which are also called metal to metal relays, which are used. This presentation deals mainly with Q style relays or plug-in type metal to carbon relays. What are the basic classifications based on which relays are classified? Before that, what is a relay? It is an electromagnetic device which is used to convey information from one circuit to another circuit through a set of contacts, that is a front or back contacts. So the relay will have a front contacts and back contacts which make or break based on the condition of the relay, whether relay is in energized condition or in de-energized condition. With these contacts we will make circuits and we use these contacts. If you classify these relays based on mounting, there are two types of relays: shelf type relays and plug-in type relays. In this, shelf type relays are obsolete and we are not using it. If you classify it based on usage, there are track relays, Rhine relays, ECRs, timer, flasher, and contactor relays. And all these relays are being used based on vitality, that is the importance of these relays. They are terminated as vital and non-vital relays. And if you take consider it on based on reliability, they are proved and non-proved type relays. So the plug-in type relays or the Q-style relays are in non-proved type, while K50 relays or Siemens relays are considered as proved type relays. If you take the feed source, then they are classified as DC relays, neutral relays, polar relays, and AC relays. Generally, AC relays are very less used. We generally use the DC relays and neutral relays, polar relays, such other relays. If you start with the characteristics of any electromagnetic relay, this is basically for any relay. What are the characteristics based on which the electromagnetic relay functions? It is based on force of attraction, effect of air gap, effect of hysteresis, and transient condition. Now let us find out what is the meaning of all these characters. Now let us start with the first characteristic of an electromagnetic relay, which is force of attraction. As you have seen, F is directly proportional to B square A, where F is the force of attraction, B is the flux density, while A is the cross-sectional area of the particular part of the magnetic circuit. So in our case, it is a relay, and the relay, whenever we give supply, the armature area where magnetism takes place, we are talking about that particular part. In case of a DC neutral relay, B is directly proportional to I. B is proportional to the current that is flowing in the coil surrounding the electromagnet. Thus, F is directly proportional to I square. You can say F is directly proportional to the square of the current that is flowing in the circuit. Now, what are the advantages when we say F is directly proportional to I square? A small change in current will give a very vast change in the force of attraction. If there is a small increase in current, there will be lot of increase in the force of attraction. Let me give you an example of a DC track relay. A small reduction in the current will have a great working on the effect of the track relay. Also, for a given change in current, the make and break will be quicker with lesser possibility of arching that is happening between the contacts. Let us explain this with an example of a track relay which is having 9 ohms. Now let us take the voltage on the track relay as 3.5 volts. Then the current on the track relay is 388 milliamps. So here I am talking only about the track relay directly. So what is the force of attraction when you take it as square of I square current? It will be 0.15 newtons, which is the force of attraction F. Now voltage on track relay is, let us say, changed from 3.5 to 4 volts, an increase of just zero point 0.5 volts. Then naturally the current will also increase to 444 milliamps. Then the force of attraction has changed to 0.197, that is almost zero point 0.2 newtons. So you can see just a small change of zero point 0.1, zero point 0.5 volts has increased the current from 1.15 to zero point 0.2 newtons. This is the benefit that we have because the track relay is very sensitive. The second one is the effect of air gap. What is the air gap? The gap that is available between your armature and the core. That air which is available will have an effect on the working of the relay. Here you can see different curves. Let me explain you about this first. This is the flux density y-axis, while this x-axis is the ampere turns or the current that is required. Here there are different turns. Let us say A, iron. This is the magnetism curve when for only iron. That is the armature that is used, while B is the curve for open air. When there you are not talking about iron here, only open air. Here it will be a straight line as you have observed at 45 degrees because the permeability mu is 1. Totally air permits the supply. While C, C is the curve when the relay is in dropped condition. What is the curve that will be for air and iron? Here the relay is still in dropped condition. Now if we go for D, this is for air which are we are not much interested, but for E this is very important. Here this is the curve for iron and air when the relay is in picked up condition. So this is the force magnetism curve when the relay is in drop condition, while this is the curve when the relay is in picked up condition. Here there are two forces of attraction, F1 and F2. So F1 is the force required to pick up the armature when the front contacts are open. That is when the relay is in drop condition and you give supply to the coils. This is the force that is required to pick up the relay. It will be separated from the core by stop pins when the relay is in picked up condition. Here you can see in this position the ampere turns required to maintain the armature is less as indicated by the dotted line from 1 on curve C to 2 on curve E. So 1 on curve C. So this is the air and iron when it is in dropped condition, while this is the point when the relay is in picked up condition. So when the relay is in dropped condition, the current required is more. So this is the current required when the relay has to pick up. But once the relay has picked up, the current required reduces here. So it is only this portion of current that is required to keep the relay in picked up condition. but we are not reducing the current of the coil. That is, the current is not reduced. So the current actually, here you can see this is the 3, that is the current available when the relay is in picked up condition. This extra current, you can say, is helps the relay in getting the contacts more pressure. The contact pressure is increased because of this excess current that we are giving to the coil. Though it is this much of current is enough, we are giving F2 up to 3 when the relay is in picked up condition. This is the effect of air gap, which is required excess pressure to hold the contact properly. Now the third is the effect of hysteresis. So what is actually hysteresis? Hysteresis is a property by which the flux produced lags behind the current. So whenever you give supply to any relay, you get electromagnetism, and when the relay is dropped, that is when you remove the power supply, some amount of magnetism is still available even after removal of your supply. So this is what is called the effect of hysteresis. In our relays, it plays a very important role. Here you can see 0 to 1 is the residual flux in the core in the de-energized condition. So let me start with here 0 to 1. This is the flux available when the relay is in dropped condition. Here actually it is not 0 but 0 to 1, because every human being or every metal, every body, every object will have some amount of electricity stored inside their body. So you can say that one here 0 to 1. When from 1 to 2, flux developed when the voltage is applied to coils. So once you apply voltage to the coil, what is happening? The density, flux density is increasing. It is nothing but the force that is on the armature is increasing from 1 to 2. So this is the pickup when the relay has picked up. From 2 to 3, the flux density increased with the same current in the coil. So here the flux density has increased. Here the current is also same. While 3 to 4 corresponds to the final current that is happening. Here the relay is in picked up condition with that current continuously being given to it. While 4 to 5, here you can see what is this 4 to 5. When flux density falls as the current is falling, so when you remove or disconnect the supply to the relay, the flux density, actually supply is disconnected immediately, but the flux density just doesn't come to 0 immediately. It will come from 4 to 5. Here the relay actually drops. Relay drops, then suddenly 5 to 6 it will come, it will reduce, and then 6 to 1 is the final decrease in the flux, where the current will be again 0. Hence, if you take this hysteresis loop in both the drop condition and the pickup condition, here I am not talking about drop condition, the relay core is has to be having a high permeability and low retentivity. Here high permeability means the whenever gives supply, it should easily pass through the iron that we are using, and low retentivity, that is the residual magnetism that is available or stored once the supply is removed, should be very low. So the relay core material shall generally be used as bar of silicon steel, best Yorkshire wrought iron. This is generally used in our relays. Also Swedish charcoal iron or electrical steel sheets. This reduces the difference between up value and down value, and the percentage release, which is very important, is improved if you use the this type of material. Coming to the Next characteristic of the electromagnetic relay, which is transient condition. What is transient? It means a momentary variation in current, voltage, or even frequency. Here frequency, there is no not we are not talking about it, but current and voltage will be varying for any track relay. So as far as track relay, transient conditions are very important, or transient voltages or play a very important role. It does not is of not much importance when we talk about a line relay, 24 volts line relay, but where plays is very important role as far as track relay is connected. Here you can see the voltage. When the relay is given with some voltage, the relay picks up the current steadies and then again increases. Here, let us see this example where T is directly proportional to L by R, where T is the time constant, L is the inductance, and R is the resistance. Here, L is generally the external resistance that is available. Here you can see when the relay current is reduced, that when the relay becomes open circuit, the voltage drops here in some time. It will not suddenly become zero, but it takes some time to come down. And when the relay drops, it will suddenly come down again. This is the normal route, but here once the relay drops, again the speed with which relay drops will be, or the current becomes zero, will be quicker. It is now clear that to reduce releasing time to a minimum, it is necessary that relay should have low hysteresis loss and low retentivity. The degree of overresistance of relay should be restricted, and connecting a suitable external resistance in series with the relay coil. So these are some of the overall characteristics of electromagnetic relay. Thank you. Jai Hind.